Let's now look at a few examples to see how we apply conditional probability in practice. Let's consider the experiment where we flip a coin twice. And suppose we want to find the probability that both flips are head, given that the first flip is a head. Now, first off, note that this is a fairly simple experiment, right? So we can go ahead and list all the outcomes, and we're gonna have 4 outcomes total, right? We can have head, we can have head-tail, we can have tail-head, and we can have tail-tail. So now let me define my event A as the event where the first flip is a head, and event B is the event where both flips are heads. Then the probability that we want to find is we want to find the probability of B given A. So here we have A, and then here we have B. So we want to find the probability of B given A. Let's first see how we do this problem using intuition. So when we want to do this problem using intuition, you want to first find what's called the restricted sample space. So identify the restricted sample space, which consists of all sample points in the event that is being conditioned on. Now that's a mouthful, right? But if you apply it to a particular problem, for example, in this problem, the restricted sample space will consist of the following outcomes. So the restricted sample space consists of the outcomes in event A, right, which is the event that we are conditioning on. So let's look at our outcomes and see which ones belong to A. First off, we have head. For head, is the first flip a head? It is, right? So it belongs in our restricted sample space. For the second outcome, we have head-tail. For head-tail, is the first flip a head? The answer is yes. So it belongs to the restricted sample space as well. Okay. The third outcome is tail-head. Is the first flip a head? No, it's not, right? So that one is out, and tail-tail is also out for the same reason. Okay. So in the restricted sample space, we have 2 outcomes, head and head-tail. Now in step 2, what you want to do is you want to find the probability of the events of interest in the restricted sample space. So in the context of this particular problem, what we want to do is that we want to find the probability of getting both heads in the restricted sample space. Okay. By definition, this is the number of ways to get both heads in the restricted sample space. Divided by the total number of outcomes in the restricted sample space. So total number of outcomes in the restricted sample space. So what is our numerator? The numerator is the number of ways we can get both heads in the restricted sample space. In the restricted sample space, we have two outcomes, head-head and head-tail. How many ways can we get both heads? It's only one way, right? And the total number of outcomes in the restricted sample space in this case is 2. So we have a probability of 1/2. And so if you write this formally, the probability of B given A in this problem is going to be equal to 1/2. Okay. So this is how we do this problem using intuition. Let's proceed and see how we solve this problem using the formula we learned in the previous video. So let's say using formula, again we define event A as the event where the first flip is a head, right? And then event B is the event where both flips are heads, and we want to find the probability of B given A. Now the formula for conditional probability tells us that the probability of B given A is equal to the probability of the intersection of A and B divided by PA, right? Remember that whatever we are conditioning on, we want to divide by the probability of that. Okay? So we're conditioning on A, we divide by the probability of A. So to do this problem, it boils down to finding these two probabilities. Let's go ahead and draw my my Venn diagram. Suppose I have this Venn diagram and I have 4 outcomes, right? Head-head, I have head-tail, I have tail-head, and then I have tail-tail. Now, to find the probability of the intersection of A and B, we need to find the number of ways we can have both A and B happen, right? Divided by the total number of outcomes. So event A is the event where the first flip is ahead, and so this circle is gonna represent my event A, because we have head and head tail. Now event B is the event where both flips are heads, and so this circle will be my event B. Okay. Now if you look at those two events in the Venn diagram, what is the intersection of A and B? Right? You have one event being the bigger circle, and then the other event being a smaller circle within that bigger circle, right? So the intersection is the part where both have in common, which means that the intersection is precisely the small circle, right? So this is the intersection of A and B, right? So in this case, the intersection of A and B has one sample point. So now we want to find the probability of the intersection of A and B. This is going to be the number of ways both A and B happen, so that's 1, right? Divided by the total number of outcomes. Notice that here we're not conditioning on anything, right? And so because we are not conditioning on anything, we use the original sample space. And the original sample space consists of 4 sample points, and so the probability of the intersection of A and B is 1/4. Okay. So now we want to find the probability of A. From the Venn diagram, we know that A contains 2 sample points, right? So A has 2 sample points, and so the probability of A is just going to be the number of ways A happens, so that's 2 divided by the total number of outcomes, which is 4. Again, we're not conditioning on anything, so we use the original sample space. So the denominator is going to be 2/4. If you do the math here, you get 1/2. And that's exactly what we got using the intuition. Is 1/2. So in this video, I showed you an example where we can solve a conditional probability problem using both the intuition as well as the formula. And both methods lead us to the same answer.